What is going on, guys? Welcome back. In today's video, we're going to learn how to implement a simple matchmaking system using sockets in Python. So let us get right into it. Alright, so we're going to build a simple matchmaking system today in Python using sockets, and the basic idea of a matchmaking system is that you want to match people together for a game, for example, for a game of chess, for a game of guessing numbers, for a game of Pong or something like that. And maybe they have different settings, so people want to play a number guessing game with a certain maximum number and with a certain number of tries. And certain people want to be guessers, whereas other people want to be deciders, so they want to make up the number, they want to decide on the number, and the other person should then guess on the number. And based on those configurations, you need to find a match. So you have maybe 100 players. One guy wants to play with a maximum number of 1,005 tries. Another one wants to play also with a maximum number of 1,000, but with 3 tries. So they are not, they cannot be matched because they have a different setting. Maybe they have the exact same setting, but one wants to be a guesser and the other one wants to be a guesser as well. So they cannot be matched. And we're going to implement a simple matchmaking system today. And for this, we're going to split the tutorial in 2 parts. We're going to do a very basic matchmaking, just matching the strings in the first part. And in the second part, we're going to actually implement a number guessing game, which works with a central server that implements a matchmaking system. So we're going to start here by creating a simple client py, and what we want to do here is we just want to say import socket, and we want to say that the client is a TCP socket, so socket AF inet to make it an internet socket sockstream to make it a TCP internet socket. Then we're going to connect, in our case, to localhost, since we're going to run this locally here, and we want to connect on port 9999. And then once we're connected, we're going to receive something from the server. So we want to get a message from the server. This is just going to be the protocol. We're going to receive 1024 bytes. We're going to decode the message. We're going to print it. And this message is going to ask us for a string. So as I said, the first example will be quite simple. We're not going to implement a fancy game. We're just going to say you can enter a certain string, and if another person enters the same string, you're going to be matched with that person. So what we're going to do is we're going to just say client.send, and we want to send here whatever the user decides to put into the command line. So we're going to call the input function. We're going to encode whatever we enter, and then we're going to then print client receive 1024 so that we can receive the match message in case we find a match. So let's go and now implement the server. This is going to be the matchmaking logic here. And the idea is quite simple. We want to have socket, we want to have threading, and we want to say that the server is, again, a TCP socket. So socket internet socket sockstream to make it a TCP socket. Then we're going to bind it now to localhost, to a tuple of localhost and the port 4 times 9. And then we're going to listen for incoming connections. And now what we want to do is we want to have 2 functions. First of all, we want to handle client connections. So when a client connects, we want to exchange the string, the pattern that the client provides. We want to store it. We want to handle this whole client interaction. And then we also want to have a match handling function. So we want to have, first of all, our main loop. This is going to be at the bottom of our script because everything else is going to come in between, so that we have the functions defined before we actually use them. But the basic idea is that we want to say the client and the address is going to be whatever the server accepts. So we're going to accept incoming connections. This function is going to return then a client and the address of the client. We want to take the client and feed it into the handle client function or handle connection function, whatever you want to call it. And we want to do this in multiple threads so that we can handle multiple connections concurrently. So we're going to say threading .thread, and the target function that we are going to target here is going to be the handle, let's call it handle client, and we want to pass here as an argument the client. Now important, we need to add a comma here because we want to pass a tuple. This is just a typing thing. You want to pass a tuple, not just a client, as an argument. So if you pass it without a comma, since it's just a single element, it will be perceived as one element. In parentheses, and now when we add a comma, it's going to be an element inside of a tuple. And then we also want to start this thread. And you can see that we already get an error because this function is not defined. So we're going to do that here. We're going to define the function handle client. And this is going to take C as a parameter, which is going to be the client. And here we're going to just say C send enter matching string. We're going to encode that message, and we're going to then say matching string of this particular client is going to be whatever it sends to us. So receive 1024 bytes, decode those bytes, and then what we're going to do now is we're going to look for a match. And in order to be able to look for a match, we need to keep track of the already connected clients. So we're going to open up a new list up here, connected clients. It's going to be an empty list. And what we want to do is we want to say, okay, found match is going to be false. So we don't find a match by default. We have not found a match by default. So we're going to say now for each client in the connected client. So for I in range length connected clients, we're going to iterate over the indices here. If connected clients I1 equals the matching string, and the idea here is that we're going to pass a tuple. This is why I have this index here, because we're not going to just pass the client. We're not just going to say connected clients.append client, or C in this case. We're going to append the client, but also the matching string here as a tuple. So we're going to have two elements per each connection. So if the matching string of an already existing tuple is the same as the one that we have here for this particular client that is connected, we're going to say that we want to open up a new thread with a new target function, and this is going to be the handle match function. So we're going to handle this match between those two clients, and as an argument here, we're going to pass the client that just connected and the client that was already waiting for a match, so connected clients I0, and we're going to start here. Now, the reason we do this with the index and not just with a for each loop is because we want to also delete the client from the list. Now, we could also probably just pop it, but I decided to do it like this. So if we have a match, we call this function that is not defined yet. So we're going to just define handle match C1, C2, and we're going to pass. But basically, when we find an already existing client, already connected client with a certain matching string that is the same as the matching string of the newly connected client, we're going to put both of those into this function here. We're going to run this function here, whatever this match then is. It would be a game if you have a game. And we also want to remove this one from the list of connected clients because it should not be matched again with another client. It should only be matched with this client. This client is not yet in the list, so we don't need to remove it, but the other one is. So we need to say del and then connected clients I. And then what we want to do at the end of the loop, if not found match. So if we went through everything in that list of connected clients and there is no matching string like the one that we have here, what we want to do in this case is we want to add the existing client. We want to add the current client to that list as a tuple. So we want to say connected clients dot append, and we want to append the list, or the tuple in this case, C and matching string, which is the same thing that we check for here. So this is why we have these indices here, 0 being the client here and 1 being the matching string. That is that. And then I think we already have the while true loop, so we don't need to care about this. But what is important is we need to also implement what happens in the case of a match. Now in this case, it's going to be quite simple. We're going to just say C1 send match encode and C2 send match encode. Nothing too fancy because, yeah, we essentially don't have a game here. We're going to change that in the second part, but let's just run this server now and let's open up the command line. I'm going to split it here into 2. I'm going to navigate to the directory that I'm currently in. Let me just CLS here. I'm going to navigate to the directory again. And now I'm going to just say Python client py, Python client py, And now if I enter ABC as my string here and ABC as my string here, we can see we have a match. Whereas if I say ABC here, oh, the problem is now I have a match again. Why is that the case? Oh, because we need to set found match to true. Otherwise, it's always going to add the client. This is the second client, right? So let's just go ahead, ABC, and now BCA. It doesn't produce a match. Now let me open up another terminal and navigate to this directory. And now I can say Python client py, and now I can match with any one of those, ABC, for example. And you can see I get a match here and I get a match here, but I don't get a match here. And we have some problem because of the deletion, but that we're going to fix that when we get to the actual game. So this is a very basic example of matchmaking. And now we're going to take this approach and we're going to implement a number guessing game with a matchmaking system. All right, so let's get started with the client. We're going to remove all of this here. So we're going to just keep the part where we create the client and connect to localhost. Before that, we want to specify in each client the settings. So we want to know, okay, what is the maximum number that you want to allow for? What are the number of tries that you want to have in the game? And what is your role? Do you want to be the guesser or do you want to be the decider? So we're going to say here that the tries is equal to int input tries. And by the way, I'm not gonna try to always do all the exception handling. So when I say int input tries, I'm just going to assume that that the user, the player, is going to enter a valid number. I'm not gonna ask, okay, if this is actually a number, then convert it to an integer or try accept and stuff like that. This is not the focus of this video. So I'm going to just keep it simple and assume that the user enters valid values. We're only going to check when, for example, the max number is 1,000 and the user enters 2,000. This is something that is part of the game logic. So we're going to check for that, but we're not going to always try to figure out if the user entered a value that is a number and that is in the range and stuff like that, in the range in terms of being a positive number. We're going to just assume that the user enters valid values. So tries equals int input tries, then max number is going to be int input maximum number. And then we're going to say that the role is going to be input role. And this is not going to be an integer because that's going to be a string, and the string is either going to be guesser or decider. And again, we're going to just assume that the user is not going to enter ABC, right? So once we have this, we're going to turn this into a configuration string. We just do this so that we can easily match this with the configuration of other clients, so that we just have to compare strings essentially. And the configuration string, so the config string is going to be an f string, and we're going to say that first is going to be the tries separated by a dash from the max number, separated by another dash from the role. That's going to be the basic string. So if anyone else has this connection string, but with a different role in the end, so basically the same number here, but then the different role, the other role, it's going to be a match. That's the basic logic here. So we can easily split on these hyphens here and then extract a role, say, okay, it has to be a different role, but the rest has to be the same. Quite simple. So we're going to do it like that. And then we're going to just say that the first thing we want to do once we connect to a server is we're going to send the configuration string. So we're going to say send config string encode, and then print whatever we get from the server. So receive 1024 bytes and decode whatever we get. And then what we're going to do is we're going to enter something, because no matter who we are, no matter if we're, doesn't matter if we're the client, if we're the guesser or the decider, we will have to make some input. If we are the decider, we need to decide on a number that the other person has to guess. And if we're the guesser, we will have to make a guess what the number is that was decided for us or that was picked for us. So we're going to say client.send input, whatever that input is. So this is, it doesn't matter what role you have, you're going to have to send this input here. And then we're going to distinguish between the different roles in the while true loop. So we're going to say while true, and the basic idea is always to get the message from the server. So client.receive 1024 bytes, decode, and then print the message. And we want to get certain keywords from the message. If those keywords are part of the message, we know that the game is over and we can close the connection, or we can break out of this endless loop. So we can say, if, for example, tries is going to be part of the message, because tries is only going to be part of the message if we say, correct, you found a solution after X tries. We're not going to mention the word tries when the game is still going on. We're not going to update the number of the tries all the time in the messages. That's at least the logic for this game that I'm implementing here. So that is that. Then we're going to say or lost in message, because when you lose, you're going to get lost. Either you lost or your partner lost. And then invalid is also going to be something that we're going to look for. And invalid is with a capital I, because it's going to be the first word. It's just going to be invalid input. Whereas this is going to be part of the sentence. So that's the basic logic. In those cases, break out of the loop, and then we're going to check if the role is equal to guesser. We're going to say client.send input encode all the time. Because for the decider, he's only going to receive messages updating him on the status of the game. So it will say something like, your partner said this, your partner said this, your partner won, your partner lost. But you don't have to put in anything once you decide on a number, whereas the guesser has to continuously provide some more input. So that is the client, quite simple. The server is where all of the logic comes into play. So I have the prepared code here. I think I'm going to look at it quite some times, because I'm probably going to make mistakes otherwise. So what are we going to keep here? We're going to still keep the socket. We're going to keep the binding. We're going to keep the listen. And we could also keep the connected clients, but I already deleted those. Connected clients is an empty list. We still are going to have, actually, let's just reverse this here. I think we can keep a lot of the basic structure. So we're going to keep that handle match function. We're going to pass here. We're also going to keep handle client, but here we're going to do something different. So the difference here is that we're not going to send a prompt, because the client is automatically going to send the configuration string. So what we're going to do is we're going to say config string is going to be whatever we receive from the client. And then we're going to parse certain things here. So what we want to do is we want to say that the config itself is going to be config string, and then up until the point where config string finds a dash from the right side. Now, why from the right side? Because remember, we have the config string being something like 10, or what was it, 10 tries, 200 being the max number. And then we have guesser, for example. What we want to do is we want to find the last hyphen, which means from the right side, the first hyphen, so rfind. And we want to take this here as the config, and this is the role, right? So this is what we want to do here, which is why we say take everything up until this hyphen, which is the first one from the right side. And actually, we'll want to then say that the role is the opposite. The role is going to be config string rfind dash one after that, because we don't want to include the dash. We want to say after this hyphen that we find, from there until the end is going to be the role. So this is how we process the strings. And then we're going to have the same loop. We're going to say found match equals false. And then for all the connected clients, if, and now here the logic is kind of different because we now don't have the matching string. We want to say, first of all, if the connected clients, and the representation is going to be the following. At least I think that is what I did. The configuration or the tuple structure is going to be the following. We're going to have the client, we're going to have the config, and we're going to have the role. The config has to be the same, so it's going to be, for example, 10 and 1000, separated by a dash, and the role has to be different, and the client is just a client. So what we want to do here is we want to say, okay, if the connected clients that we have, if the last position, which is the role, if the last position of an already connected client is not equal to the role, only then we're going to consider it. So the role of the currently connecting client, which is not part of the list yet, this has to be a different role than the role of the client that is already in the list that we're now considering. Because if they have the same role, we cannot match them. So we're going to ignore them otherwise. Before that, we're going to see if the configuration is also the same. So connected clients I1, which is going to be the config string. This has to be the same as the config that we have. So the config is only tries and max number, and we are going to save it like that into the list. So if this element here, if this config here is the same as the config of the connected client that's waiting for a match already, and the role is different, then we have a match essentially. So first of all, we can just log this here as a match on the server side, and then we're going to also create a new thread. We're going to say that the thread is going to call the handle match. We're going to pass the client. We're going to pass, in this case now, something different. We're not going to pass the two clients only, because what we want to do is we want to pass the full tuple or the triple of the already connected client, which is just I without providing an index. And we also want to pass our own triple here, which is C, config, and role. So I'm going to explain this here in a second again. What we want to do here as well is we want to del, and we want to break afterwards because we don't want to continue looking when we already have one. And then we also want to, before we break, we want to set found match to true. And if not found match, we want to append the config and the role here. Okay, so let me just again explain what we do here. We get the config string, we separate it into the config and into the role. We go through the already connected clients. The config has to be the same, the role has to be different. Then we're matching. And if we're matching, we're passing to that handle match here a triple of the client that just connected, that's trying to connect and that is not part of the list yet, with its config, with its role. And we also pass here the already connected client, which is also a triple of the client, the config, and the role. We pass it to handle match. We delete the client that we just matched from the list. The first one is not even in the list yet, so we don't need to delete it. We set found match to true. We break out of the loop so that we don't continue to look for matches. If no match was found, we append the client that is just connecting to the list so that someone else can match with that client, and that's the basic logic. So now the handle match is basically where the whole game logic is. So the matchmaking is already implemented. The game logic is now in handle match. So what we want to do here is we want to say tries and max number is going to be, we can pick any client because they have the same configuration. So we're going to say the configuration, we want to split that configuration on the dash, on the hyphen. And we then want to also convert these values into integers. So we're going to say that whatever we split is going to be typecast into an integer. And then we're going to decide who is, or we're going to determine who is the decider and who is the guesser. And we want to have it like that. So we're going to say if client 1, if the role of client 1 is not the decider, of course, in quotation marks. So if the first one, if client 1 we're passing here is not the decider, but the guesser, we're going to swap them because we're going to implement our logic in a way that C1 is the decider and C2 is the guesser. And if it's the other way around, we're just going to swap it. So we're going to say C1, C2 equals C2, C1, which is just swapping essentially. Once we have that, we can get into the logic. We're going to send to the decider. So to client 1, we're going to target index 0 because that's the actual client. To that client, we're going to send a message, enter the number to be guessed. And we're going to encode this, of course. We always need to encode everything and to decode everything because we can only transmit bytes. And we're going to say that the number is whatever we put in here. So whatever we get from the client. So we're going to get the client. We're going to receive 1,000. 1024 bytes. We're going to decode them, and we're going to typecast this into an integer. That is going to be the number that has to be guessed. We're going to check now if that number is actually less than the maximum number. We're going to actually check if it's above that maximum number, because then we're going to terminate. We're going to say that this is invalid. So we're going to stop everything. We're going to say C10 send invalid range, which is the keyword invalid. So we know already on the client side that when invalid is part of the message, we're going to break out of the main loop. We're going to encode this here. We're going to also send to client 2 the information that your partner messed up, invalid range. Again, the keyword invalid here with a capital I. And then C10.close and C20 close. So we just close the client connections here. And then what we want to do is, otherwise, if the number is actually in the range, we're going to start the basic game loop. So we're going to say that guessed equals false. The number was not guessed yet. We're going to say try counter equals 0, meaning that no try was used. And then we're going to send to C2, to the client C2, enter your guess. And of course, in quotation marks here. And I'm going to encode this. And then while the number is not guessed, so while not guessed, we're going to increase the try counter. We increase it at the beginning of the loop because we started with 0, and once we enter the loop, we have our first try. So even if we manage to guess the number immediately, it's going to display 1 and not 0. So you needed 1 try, not 0 tries, because even if you guess it immediately, it's 1 try. And then we're going to say that the guess is equal to integer C2 0. So we get the second client, which is the guesser. We get the guess by receiving 1024 bytes. We decode the message, we decode the guess, and we turn it into an integer again. And now we just have to compare it. We're going to say if the guess is equal to the actual number, then we have 1. So we can say C20.send. Correct. It took you try counter tries. And again, here we have the keyword tries, which is recognized. So we're going to break out of the main loop. And probably there's a more efficient way and more professional way to do it here, but I'm just going to check for those strings here. I didn't want to do all this sending some flags and sending some special symbols. We're just going to do it like that. And then we're going to also say C10 send your partner guessed correctly after try counter tries. I'm going to encode this. And then we're just going to close the connection again. So close the first client and the second client, and guessed needs to be set to true so that we can break out of the loop. And otherwise we need to say, okay, the number is too high or too low. So otherwise, if the try counter is larger or equal to the tries, and the important thing is that we check this here and not before, because let's say we have 8 tries. If I am in my eighth try and I guess correctly, that's fine. It's only when I'm wrong on my last try that I want to display that I lost, right? So here, if we didn't guess correctly and we are already at our last try, or we were already at our last try, we're going to say C20 sent you lost, the number was, and now the number dot encode. For client 1, we're going to say your partner lost, the number was whatever. And again, we're going to close the 2 clients. Otherwise, and we need to also break out of the loop. Otherwise, if the guess is less than the number and we still have some tries, we're going to say C20 send your guess is too low. Try again. And we're going to encode this. For C1, we're going to say an F string here. Your partner guessed and then just a guess. And I think that's it. Then we can say elif guess larger than the number. We can copy this. And we can say your guess is too high. That should be it. Now, I'm not sure if this is going to work right away because I'm pretty sure I have some mistake in it. But let's see. We're going to run the server now. We're going to connect again with some clients. So we're going to say Python client. We're going to say Python client. We're going to say Python client. Let me maybe just increase the font size for you guys a little bit. If that's possible. Maybe like this. Let's say we want to play with 100 tries here and a maximum number of 1,000 here, and I want to be the guesser here. Let's say this guy wants to do the same thing, 100, 1,000, and a guesser. That is not a match, but if I say here 100, 1,000, and a decider, then we have a match. Now, we're not displaying here that we have a match with one of those two, but when I enter the number to be guessed, so for example, I want to guess the number, what was the maximum? 1,000, let's say 766, then obviously I have a match with this one because he got the message into your guess. Let's say my guess is 50, your guess is too low, try again. Your partner guessed 50, okay. Let's go with 800. Your guess is too high, try again. Okay, your partner guessed 800. Now let's go with 750, too low, 760, too low, 770, too high. Let's say I go with 766. Your partner guessed correctly after 6 tries. Correct, it took you 6 tries. Okay, this one's still waiting for a partner. Let's give him one. Let's say 100, 1,000, and decider again. And now let's go with 1,000. Let's go with 999. Enter your guess. Let's say we cannot get it right. I'm going to guess incorrectly a couple of times. Now somehow this, we entered 100 tries. Okay. Now I don't want to press this now 100 times. So let me just, I'm not sure if I can actually just exit. So I'm going to just do this again here. So let's say 10 tries, 1,000 the maximum number, guesser. Let's do 10 tries, 1,000 the maximum number, decider. Let's say 999, and let's say 1, 1, 1, 1, 1. 10 times, you lost, your partner lost, the number was 999. So you can see this works, it works with different configurations, it works with different roles. Basically, it works when the configuration is the same, when the roles are different, but you can see that the matchmaking works and the game works. And this is how you implement a simple matchmaking system in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.